Hello everyone. So I just wanted to provide a quick proof of the Pythagorean Theorem. This is what I think is probably one of the simplest and easiest to understand proofs of the Pythagorean Theorem. To the best of my knowledge, this proof comes from ancient China. They probably came up with it somewhere around 3,000 years ago. And I'm just going to use a little bit of algebra in order to make the proof more visual and make more sense. All right, so what is the Pythagorean theorem? The Pythagorean theorem says that when you have a right triangle, that if we take the squares of the sides and add them up, then we're going to get the square of the hypotenuse. All right, so more familiarly, that sounds like a squared plus b squared is equal to c squared. This is what we're trying to prove. Okay, well, suppose we start with this right triangle and we don't know anything about the side lengths, right? We'll just call them A, B, and C. The only thing we know is that this is a right triangle. Well, suppose I took that same right triangle and copied it, right, and just kind of laid it on its side right here. All right, so now I have another triangle here, where right triangle, where we have this B is the short side, A is the long one, and C is our hypotenuse. All right, now let's suppose that I did that again. I'm just going to take that triangle and kind of turn it on its side here. And we'll say this is B, this is A, and this is still C. Let's do this one more time. So I'm going to create this triangle again, right, where I have sides B, A, and C. All right, now what have I created? I've actually created a square, right? This square has side lengths of A plus B, right, on all sides. So if I wanted to look at the area of this square, then I could say that the area of this square is A plus B squared. Right? That's when I look at the whole figure here. Well, what happens if I look at the individual pieces that I've created here? What do I have? I have 1, 2, 3, 4 triangles that are all the same triangle, right? Well, in order to find the area of a triangle, recall that is 1/2 of the base times the height. Well, in this case, our base is A, our height is B, still taking half of that, but I have 4 of these triangles. Right. I also have this square inside in the middle that's a square of side length C. So we could say that's also C squared. All right, so what happens when I simplify this? 4 times 1/2 is 2AB plus C squared. But these areas are supposed to be equal. Right? The area of the square and the area of the smaller composite figures inside, these should be equal. Right? So I'm just going to go ahead and expand this out a little bit. Right? We'll say that's A plus B times A plus B. Right? Get rid of that squared. And this is supposed to be equal to 2AB plus C squared. Right? Now what happens when I do this distribution here? I end up with A times A times B, and B times A, and B times B. Or I end up with A squared plus, here's 1AB, here's 2AB, and I have B squared as well. And this is equal to 2AB plus C squared. Now, if I go and subtract 2ab from both sides of this equation, I end up with a squared plus b squared on this side, and that's equal to c squared. So there we have it. I was able to prove the Pythagorean theorem just using a couple of little figures and some algebra. So I hope you enjoyed this. I think it's a pretty cool proof.